Oh, Jesus.
You ever wondered the physics involved in tennis? I'm Quinn McGinnis from Macaulay School for Boys, and I'm here to tell you that science is tennis. Physics is in tennis. Let's start with Newton's 3 laws of motion. Here, come with me. Newton's first law of motion, also known as inertia, states that every body continues in its state of rest or of uniform speed in a straight line unless acted upon by a non-zero net force. Where are we right now?
Earth!
We're on Earth! Now, bear with me. Let's say we're in space.
Space?
In space, this ball, I'm gonna hit it, it's gonna keep going. And it's not gonna drop.
Why not?
There's no gravity. So, here we're on Earth. That's gravity right there, boys. That's gravity. Okay. So you could say, gravity, that's why we can play tennis. Now, Newton didn't stop there. He's got 2 laws. Actually, he's got 3, but this is the second one. Newton's second law states, the acceleration of an object is directly proportional to the net force acting on it and is inversely proportional to its mass. The direction of acceleration is in the direction of the net force acting on the object. So, in the absence of a gravitational pull, there would be no acceleration. I wouldn't be able to do this.
Wow.
Ace. Cut. Force equals mass times acceleration. Number 3, Newton's third law of motion. Whenever one object exerts a force on a second object, the second exerts an equal and opposite force on the first. What does this apply to? Tennis. Tennis. Look at that. Cut. Basically, Newton's third law of motion states that the force on the racket to the ball is equal and opposite to the force of the ball on the racket. So, now we've studied Newton's 3 laws of motion. Now let's travel on back to law number 2. Law number 2 states that force equals mass times acceleration. So, what does that bring us to? The study of kinetic energy involved in tennis. Now, work equals force times distance. So, knowing that work equals force times distance, you can also go back to the equation for force and conclude that work equals mass times acceleration times distance. So, that explains a lot. One thing it explains is why more energy is used when you use a heavier racket. So, because this wooden racket is so bulky, heavy, and able to morph, it brings us to the modern racket. Not only is the modern racket strong, it is also extremely light. That's a hard ball I just hit. So, what is important about having a light racket? Well, it just brings us right back to Newton's laws of motion. You want your racket to be able to swing as fast as you can because the force you apply is going to return to the ball. And the purpose of tennis is to make it so that the other opponent of yours cannot return the ball. So, we know that this is a lighter racket. Something that comes with it being lighter is it has a higher vibration frequency, meaning that when you hit the ball like this, the racket will vibrate in your hands. And because this racket is lighter, it will vibrate more. It is able to move more, and you'll feel it in your hand more, which is why you often see a shock absorber right around here in the racket. I don't actually have one for this video, but you understand the concept. It is also because of the strong, stiff frame that it vibrates more. 15 love. Ace. What a hit. Let's talk about topspin. Let's talk about topspin. In topspin, you hit the ball about like that, slightly on the top, it keeps turning. In topspin, the ball will spin like this, and because of the Magnus effect, it will fall sooner.